Welcome to GATE 2021 model courses on control systems. Today's our topic is state transition matrix. Let us see the question number 1. So they are given a system x dot equals to x and asking for us to find the state transition matrix. These are the given options. Or what is the formula to find the state transition matrix is phi of t is equals to e power at is equals to inverse Laplace transformation of si minus a whole inverse. Or find si minus a, then take inverse. After that, take inverse Laplace, definitely you'll get the state transition matrix. But here we'll use the properties of state transition matrix to find this answer. And what are the properties of state transition matrices? One property, familiar property, which all of you know, that phi of 0 equal to I. That is, when you substitute t equal to 0 in the state transition matrix, we have to get the identity matrix. The second one is a main important property, that is phi dot of 0 is equals to A. That is, when we differentiate the state transition matrix and substitute t equal to 0, we have to get system matrix A. Using these two properties, we can easily answer this question. But first, you have to check in all the options first property. If only one option is satisfied the first property, that is phi of 0 equal to I, then that is only your option. If more than one option is satisfying identity matrix, or whichever the options are satisfying I property, for that options only, test the second property, phi dot of 0 equal to A. With that, your answer completes. Let us see the first property in all the four options. For when we substitute t equal to 0 in the option A, what we'll get it is 3 minus 2, this will be equal to 1. When we substitute t equal to 0 here, minus 6 plus 6 is equal to 0. If we substitute t equal to 0 here, we'll get again 2 minus 2 is equal to 0. Here if substitute t equal to 0, 3 minus 2 equal to 1. So what you are getting here, 1, 0, 0, 1, which is a identity matrix. So option A is satisfying the first property. Let us see the next option also. If you see the remaining all the options, just check it out. T equal to 0, you'll get 4 minus 3, 1. Here minus 6 plus 6, 0. Here 1 minus 1, 0. 3 minus 2, 1. So this is also satisfying identity matrix 1, 0, 0, 1. See the remaining C and D options also. 3 minus 2, which will be 1. Minus 6 plus 6, which will be 0. 1 minus 1, which will be again 0. 3 minus 2, which will be 1. This is also satisfying I property. Last one, 3 minus 2, 1. Minus 2 plus 2, 0. 1 minus 1, 0. 3 minus 2, 1. All the options are satisfying the identity matrix. Therefore, for all the options, test the second property. For directly whichever will give the A matrix, that is only your option. No need to check all the answers also. If you're getting option A only A matrix, then you can forget it and you can select A only. But let us go for the second property to check. That is, what is the second property is phi dot of 0 should be equal to A. That is, differentiate the state transition matrix, then substitute t equal to 0, we have to get A. But here we'll differentiate it. If we differentiate this one, we'll get minus 6 e power minus 2t. Substitute t equal to 0, what we'll get it is minus 6. Here also when you differentiate and substitute t equal to 0, you'll get plus 6, which is nothing but 0, which is matching this one. If here itself it is not matching, you can skip that option. Okay. Next, differentiate this one. If you differentiate it, you'll get 9 into e power minus 3t. Substitute t equal to 0, we'll get 9. Minus 6 into 2 is 12. 9 minus 12 is minus 3. But here they are given as 6. But here itself our option A is becoming wrong. No need to check the remaining things. But actually A is wrong option. Go for the B option. Differentiate this one, substitute t equal to 0, you'll get minus 8. Differentiate and substitute t equal to 0, you'll get plus 9. 9 minus 8 is what? 1. But actually here it is 0. For B is also wrong. Then go for the option C. Differentiate this one and substitute t equal to 0. It is same as here. That is minus 6 plus 6, which will be equal to 0. Differentiate and substitute t equal to 0. What we'll be getting here is 6 into 3 is 18 minus 6 into 2 is 12, which is nothing but 6. Satisfying here 6. Okay, next go for this one also. Differentiate and substitute t equal to 0. What we'll be getting is minus 3 plus 2, which is minus 1. That is also satisfied. Lastly, go here. 3 into 3 minus 3 is minus 9 plus 4, which is nothing but minus 5. That is also satisfied. That is, we are getting A matrix for the C option. No need to check the D1 also. Hence, our option is C itself. But actually, what is this method actually indicates is whichever the properties are whichever the options are satisfying the first property phi of 0 equal to I, then the next property phi dot of 0 will give definitely A matrix. That is, if the A matrix is in this manner 0, minus 3, and this one also when you differentiate it and if you substitute t equal to 0, what you'll get it is minus 6 plus 4, which is minus 2. And if you differentiate and substitute t equal to 0, minus 9 plus 4, which is minus 5. So what is the A matrix of option A is 0, minus 3, minus 2, and minus 5. Okay, wait a minute. Yes, welcome. 0, minus 3, minus 2, minus 5. If this is the A matrix, really if they are given, then that option A is only a state transfer matrix. Like this, we can easily find out the state transfer matrix of a given matrix, say mainly for your main competitive examination. It can be engineering services, GATE, DRDO, anyone. If you get a state transfer matrix whenever they are asking, whatever may be the dimension of a matrix, just using these two properties, we can find the state transfer matrix easily instead of going to the normal formula inverse Laplace of Si minus A whole inverse. Because in that method, actually, you have to do the partial fractions, you have to take inverse Laplace, then only we'll have this answer. Okay. Next, we'll be continuing with a new model questions and new methods to solve your problems. Okay. Thank you very much. And please post any doubts if you have. Please comment in the box. Okay. Post your comments. Thank you very much.